Hey folks, happy Tuesday, hope you're doing well. We have gotten to week 14. My goodness, I don't know where summer has gone. Oh, I should turn on the music, shouldn't I? There we go. Slide that down a little bit. Alright, so relatively quick night. We're going to talk about a couple things, design patterns, and then any questions you had about graphics, effects, and media. Sorry I missed you last week. This getting back to around people and picking up people germs has been awful. Coughed my voice out and then just had no voice at all. So I'm off the cold meds, so I'm feeling much less loopy, which is nice. So we'll spend some time talking about design patterns tonight, and then any other questions you have about your final project. Get the rest of the time to work on it. If you folks want to meet together individually or with your pairs, trios, just let me know. Happy to jump on, or we can do that during regular office hours. Tomorrow, 3 to 4:30 or 10 to 11 p.m. And next week is presentation week. So we're going to get together on a Zoom call. I'll put that info in D2L. Still can't see out of these. And then you folks will have a chance to present your team, go through how it works, show me that you're accomplishing all the required objectives in the rubric, and then we'll be good to go. So after we finish early, I'm going to go work on scoring those midterms, the rest of the projects. I think the rest of your quizzes are in except 12. Gotta get all that in. I don't know where the time went, folks. It has been rough, but I appreciate you hanging out with me. NetBeans is still trying to start. I thought I'd try and start it early, and it didn't work. So we're just waiting on NetBeans here. Come on, NetBeans. There you go. Nope, it just wants to be slow. So, hope you folks are doing well tonight. Kind of a small crowd tonight. That's okay. We're just hanging out. So, a couple design patterns specifically we need to talk about come from our objectives here. And I think we've picked up the rest of them. Overall architecture of Java applications, how modules are compiled and executed in a Java runtime environment. How we can take our Java modules and compile them. A dad joke, you got it. You know, this weekend when we were up at family camp, we had a dad joke contest where myself and another dad went head to head, and the first one to laugh was the loser. We had a lot of fun. The crowd, maybe not so much, but you know, maybe that's part of the fun. So our vacuum cleaner that we got years ago, like when we first got married, broke. And it probably should have lasted a lot longer, but it was just like a cheap little vacuum cleaner. And we went to go, I was going to go look online for one, and my wife said, make sure you buy one that doesn't suck. And I kind of got stuck there and didn't really know how to proceed. Right, Java runtime environment, how we execute in the runtime environment. That's the virtual environment that executes the Java bytecode. We can illustrate the proper use of inheritance, composition, polymorphism, access specifiers, public, protected, and private, abstract classes, and interfaces. We did this one with our project. We have static class members, fields, and methods are created and used. Describe how they differ from instance fields. I don't know if we've done a whole lot with static. We talked about it once we did our another look at classes, but I don't recall if we did a whole project on that one. We write Java code that illustrates the use of exception handling, including user-defined exceptions. I didn't actually ask you to do user-defined exceptions because I think they're silly. If you can use regular exceptions, you can do user-defined exceptions. You just inherit from exception. It's not too big a deal. Java code that performs basic stream input and output operations, buffered and non-buffered, including sequential and random file operations with text and binary content. We did binary content with our saving our games. We did code that defines swing or Java FX GUI components with multiple layouts and associated event handling. Right, that's what we're doing now for our final project. Java annotations like @override, yes, and design documentation for program defined components, classes, interfaces using standard notation like UML class diagrams. We didn't do a whole lot of this. My apologies. I think we talked a little bit about some UML, but without having the lab computers, trying to get Visio up and running is kind of obnoxious. I just do it in Word because it's easier. UML class diagrams, and then we'll talk about singletons, adapters, and factories for our talk tonight about design patterns. So singletons is probably the easiest one. Let's talk about. We'll do that one first. And get things to respond. Maybe it'll just be a short night. Maybe. Okay. All right, so we'll start up a new project. All right. And let's make sure this one's in 2151. Well, this will be our design patterns. Now, again, we're just kind of touching on a couple of them. This is a whole, typically a 400 level course you might take in a computer science program when you learn all about design patterns. There's a great book written years and years and years ago that's still like the standard on design patterns in object-oriented land. Oh, man, it seems laggy. Is it really laggy? I don't know why my computer's upset with me now. I can quit that one. I quit Discord. If that improves anything. Sometimes Discord's a big hog. Task manager's not responding. You've seen that one of those meme posts that went around is like Anakin and Obi-Wan. He's like, you're not supposed to join them when task manager doesn't respond. That was a good one. Oh my goodness. Nothing's running. Okay, Edge is taking up all sorts of resources. What do I have open? Just the syllabus. I can close that. Is that any better? I have one other open. I'll close that one down. Maybe that'll free up everything here. We'll blame Edge. Hey, look at that. Now things are faster. Now it's NetBeans being the hog. GRD. You know, I thought it was GOF, the Gang of Four, but it's been, honestly, it's been a little while. All right, we good so far? Oh, it's still loading. Let me see. I think it's Gang of Four. No, design patterns. Yeah, here it is. GOF. Yep, they even have their own website. Look at that. Behavioral, creational, and structural design patterns. Now that Eric with an H, that's an interesting spelling for Eric. Definitely not correct. So, capabilities and pitfalls of object-oriented programming and several design patterns. This one's great. Look at that. Very cool. So this, again, is a whole class you might take. Lots of really interesting things here. We're looking specifically at the singleton design pattern to start and talk about like the intent, the motivation, why we might want to do it. If you only want a single object available, is what the singleton's for. You have a single instance of that object and then it gets shared among all of them. So in this case, like a single random generator object. This is maybe not quite as important for us because we're only doing single-threaded applications and it shouldn't be a big deal here. But the idea that every time you make an instance of random, remember it uses the system clock time to seed the random number generator because it's pseudo-random. So what you get if you create the instance of random too quickly, like if we're iterating through and maybe doing some simulations on lottery numbers, if you create two instances of random too quickly, if your computer's fast enough, they'll have the same system clock time, and then you're going to get the exact same numbers out because it's not actually random, it's only pseudo-random. So this can make a global random number generator. So the weird thing is you have this private constructor that you can't call, so you can't make an instance of it here. But it creates one itself at the static level, again private, and gives you public methods for getting the values out. You can return that instance of itself out. So if we wanted to add a, and I don't know, do we want to plagiarize the whole thing? This is it. Like that's the class. And I'm a little upset by their lack of new lines, but I guess it makes it a little prettier here on a website. Right? And there's other things we can do with singletons a lot of times when you deal with logging in an application. Right? You probably are going to have one logger that's up and running that's writing to some file log somewhere. You don't want to make new instances, open and close the file every time. You want to leave it open with that single instance and then just have it write. That's going to be easier for you to use, and it's going to perform better because I/O operations are really slow. Maybe having a single logger that you can use to do that is fantastic. So the singleton pattern, it really depends on if you should have one thing and only one thing, one instance around here. Well, we don't want to steal his whole code here, do we? That's fine. We do like logger. Singleton logger, maybe? How about that? We'll do a singleton logger. Okay. And again, we're going to kind of follow a lot of this example here. And we can even cite our source. Look at this. We'll cite our source here. And we can grab some of these methods and just change them up as we go. Right, so the idea is we have a private constructor that does something here. So this one's not done yet, right? This is not actually what we want to do. We don't need to get the seed. We don't need to get that one. We don't need, which one? Public void. We'll write log for a string message. We'll finish that out in a minute. We can log a message. We don't need the next int. Get instance here will give you a singleton logger instance and a singleton logger. The instance equals a new singleton logger. We don't need the private random. We need a private print writer. Add our import here. Right, so our constructor then should instantiate the writer here, this private writer. So we're going to say writer equals a new print writer, log.txt. And we either need to try catch or throw. Now in this case, we might just want to throw, right? And just whoever's using the logger has to deal with that for now, because I don't know, we don't really know what to do with that yet. If this one fails, then well, someone else needs to know about it here. So then for log, we're going to take writer.println message. And we'll make a new singleton logger. So this one will also then set unreported exception must be caught or declared to be thrown. That's what we want to do. Fine. I want the other hint. The other hint. So we just add the throws. Oh, goodness. Where's our hint here? Where do they want it? No, we don't want that one. We want to fix this one. Alt Enter. There we go. That's the only hint. All right, forget that. That's just upsetting us. So we'll just try catch. Why not? This is lazy, but that's fine. Again, if our logger is failing, I mean, hopefully someone's going to see it, but that's okay. This will at least make this not complain at us too much. So now we can get the instance out, right? Because we need the instance to have this file here. We're going to log, and then we want to, it's flush. So flush ought to make sure that we clear that buffer to make sure it's all written here. So we can use this logger here. So then in our design patterns, we can get that instance. We can have a singleton logger. Singleton logger. Singleton logger.getInstance. Did I spell it wrong? Oh goodness, I put it in the wrong package. There we go. Yes. How did that happen? How did that end up in a default package? All right, now we have a logger, and then we can log messages with it. Logger.log test. All right, so we run that. We should get a single way of logging messages here to our file. And then we can use this logger anywhere else in the application, and it's all going to log to that same location. We don't need to deal with having that file tried to be open and closed and open and closed and open and closed and different things accessing it. We only want one location, one part of our program to be accessing that. So we don't run into any issues there. Compile and save thing kills me. All right, now let's see, do we get our log file? Log.txt, we have test. Also, we run it again. All we get is test, right? Because we're overwriting, we're not doing append mode. So maybe we'd actually want to do it with append mode. And again, you know, that's fine. Use. We'll just leave a little note for ourselves. So maybe we want to, maybe not. Maybe you just want to have a single log file for that time that it's running. Totally up to you, right? Whatever's going to work best. Is that working better now? I think that's working better now. There we go. Can't even close Task Manager. Oh goodness, it's gonna be one of those days. It's gonna be one of those days. Yep, still waiting, Task Manager. Still waiting. All right, folks, that's it. It's okay. We'll just leave it alone, I guess. NetBeans is running, so. All right. So that's the singleton. We also wanted to talk about the adapter. So the idea with an adapter design pattern is where we need one object that we want to use, but it doesn't really fit the way that we want it to fit. So a lot of times we have maybe a given object that is in a library that we don't have access to. Right? We can't change the library, but all we get is here's the functions you can use. So what we can do is we can write an adapter to make a different object fit into that one. So it makes objects work nicely with the way that you're expecting them to work. Right? So two objects don't really talk to each other because they don't have the same interface. They don't have the same methods, whatever it needs to be. So we write an adapter that can make one talk to the other. That's our adapter design pattern. That's the adapter pattern. Right? So we have the interface and we're implementing it here so that it will fit. So we can be used with the other. Converts the interface, it can be used with the other if they're not compatible. Right? Pretty much, it's the interface without having to know the class used to implement the interface. Again, we get kind of reusability of the older functionality. Lots of different ways of adapting. This one's a little harder to do a quick example here. There's like, hey, we could change a date. If the date comes in this format, we can adapt it to a different date. Right? Or we might have flags, this sort of thing, depending on what we want to store. Okay? So this can be super helpful when you've got code you want to use, but it just doesn't quite fit the way that you want. We can adapt the specific request to fit just a regular request. And then the factory is really fun. I'm fond of the factory. Now there's abstract factories, factory methods, so a couple different ways of creating things. So it depends on what exactly you want to do here. But one of the early examples we did here, which was kind of fun, was with like this rectangle object. Right? And rectangle was a polygon, square sort of thing. Maybe we can just copy paste that stuff real quick. No, we'll just do it. We can write it real quick. So we'll have a private for length, private int for width. And then we need a constructor and some getters. So again, no sets, because we don't want these to change. Once you make an instance of rectangle, we want it to stay. So we're not going to write setters, we're just going to write the getters. And we also have a get area and get perimeter. Get area, it returns length times width. And a get perimeter, perimeter, returns length times 2 plus width times 2. Length, spell that properly. And there's a quick little rectangle. And then we can write a square if we want. And we can say, hey, the superclass is rectangle. Look at that. No, oh goodness, that did the wrong one. Nope, sorry. We want our rectangle. There we go. And now it's going to be upset that we don't have that constructor to call length and width. Right, so square just needs a constructor. Square takes an int length. And then we can call the superclass constructor and give it length and length. Right? Aside from that, that's about it for a square. Right? Not too big of a deal here. Then what we can do is can write a cool class called a factory, then that will give us instances of objects. So maybe we make like a rectangle factory. And the rectangle factory job is to give us rectangles. It will create rectangles. So we're going to write a method that gives a rectangle. Rectangle. I don't know, like create rectangle. So we'll make a new, I don't know, we can take arguments here if we want. Int length, int width here. And then we can return new rectangle given the length and the width. And now this doesn't seem super helpful at all here. But what's neat is we can make other factories. We can have a factory interface that will create a rectangle, and it can give us subclasses of rectangle. this idea with our factory. Right? So we say, hey, I will actually make you, with this concrete factory, I will make you real objects of that type. And we can implement this abstract factory to do it. So we'll have an abstract factory that's like interface, and then we can implement it with a given specific type here. So we're going to isolate our concrete classes. We can kind of have this product family, right, where product 2 really is a product here. Right? A1, A2, they're both types of A, and you might have 2 that are types of B. They can produce different types depending on what we want to do. So this rectangle one's a little bit silly. There's a really nice example with like a maze factory. And the idea is when you build a maze, you ask the factory, hey, give me a new room, and it gives you a room. So if you're working with the factory interface here, I guess maybe we should have made this an interface here. That's fine. So public interface rectangle factory, and we can just make one here. So here's the interface. We'll rename that here. Refactor, rename, interface. I like putting the word interface in. And then we can actually implement one then. This will be our square factory. And that implements our rectangle factory. Oops, we renamed it, didn't we? Interface. Did that not make it all the way through? There we go. And yeah, implement our abstract method. All right, so create a rectangle. Great. Now in this case, we can actually make squares if we wanted. Turn a new square of, I don't know, we could just do random. We could do 40. It doesn't, our case doesn't matter much. We'll have a square factory. We can also then make a new rectangle factory. Or the concrete rectangle factory. That will implement a rectangle factory interface. And this one can make rectangles. Rectangle of size 4 and 2, sure. And again, you know, we could do other things, other interesting stuff with these here. We could have constructors that take parameters, whatever we want to do here. But the idea is that then we just say, hey, when I want to build this brick-breaking game, as long as you give me a rectangle factory interface, I'm good to go. I can call a create rectangle method. And then in your game, you can go swap it out and say, okay, here's one that makes colorful bricks, or here's one that makes really long bricks, or here's one that makes square bricks, or here's one, as long as it has a method that matches, we can make any type or subtype of this object. So factories are really fun. And again, with that maze example, you could swap out the whole theme of the game, right? You could have a some sort of like dungeon style maze that will generate all sorts of like dungeon rooms with descriptions and things like that. Or maybe you have more of like a mine maze generator that says, okay, you know, here's the mine that you're in, and you've got ore on the walls and mine carts around or something like that. Or you could generate like a jungle maze where you're going to get all the rooms that is generated have like jungle descriptions. So you can swap out the implementation by using a factory that creates objects that either this type or subtype of, and we can customize it. So by using a factory object, it's easier to swap things in and out. That's a bit about it for design patterns. Again, there's a whole course on design patterns you can take, which is so cool. You can do this free one here, or again, like in a bachelor's program, is typically a 400 level course for computer science. We'll talk more about design patterns, which are super cool. And the idea is that we're sort of actually getting away from inheritance. Inheritance is very useful for certain cases, but it's not the only tool we have. More often than not, we want to lean towards composition, which says, hey, here's one object has a type of another object. It's not is a type of this. Because then you're really locked in. If you have a type, you can do a whole lot more with it. It's a lot more flexible. All right, so let me commit this for fun. We didn't do an adapter example. I'm sorry. We could if we need to. Those ones are maybe a little trickier to come up with basic examples for that are quick. Singleton and factory. Excuse me. All right, other than that, we've got time to work on the final project tonight. Again, the goal is you folks get it done. So if you are stuck in anything, please let me know. Reach out. Let me know what I can do to get you moving again in that right direction, so that next week you can demo something you're proud of, have something that works, get the full points there, and we can move on and hopefully get somewhat closer back to normal, although that's looking weird for the fall with this most recent outbreak. But you know, we'll see. We'll see. We got a nice email from our provost saying, hey, it looks like all of our online classes are filling up and having wait lists. Maybe you guys should offer more online classes. Go talk to your deans. So, yeah, people seem to want the flexibility of online, or maybe even the safety of online, or a lot of us faculty members who are nice and old are concerned about getting sick as well. So, we'll see. But the plan is still to do in person with a mask mandate, and hope that helps. So, yeah, see how it goes, I guess, and we can adjust if needed. All right, folks, any other thoughts, questions, concerns? The task manager, nope, task manager's still stuck. That is the saddest thing. It's so sad. I can close task manager, force close task manager. All right, friends, I don't think it's not running well enough for you to send a raid off anywhere, so we can just call tonight. I'll be around in Discord, email, text, call. Let me know what I can do to help. We got the rest of tonight to work on it. Again, office hours, Wednesday, or tomorrow, right? I know what day of the week it is. 3 to 4:30 and 10 to 11 are still open. And then next Monday as well, 3 to 4:30 and 10 to 11 is still open for you folks as well. So let me know what I can do. If those times don't work, we can try and arrange something else. So, all right, folks. All right, if nobody has any other questions, then we'll call it a day. Please take the time and get working on the project. I know I've had about a month to work on it here, but we're coming up to that due date pretty quick. So let me know what I can do. You take care.